Hello, this is Miss Goodwin, and today we are covering Objective 4.3.1, the Law of Sines. Today's objective is that we can use the Law of Sines to calculate the missing sides and angles of any triangle. Now, notice that we are working with any triangle. The past few objectives dealing with SOHCAHTOA and the Pythagorean theorem have been strictly methods to find sides and angles of right triangles, which have a 90-degree angle. Now we are working with any triangle. So let's take a look at our formula right here. This is what we call the law of sines, which is really the ratios, ignore that, the ratios of any side to its corresponding angle is equal to the other ratios of sides to their angles. So how do we figure out our corresponding angles? Well, let's take a look at this triangle right here. So let's start with angle A. Side A is going to be across from it on the triangle right here. So that is angle A and side A. Now angle B can be any one of the other two angles. Doesn't have to be the top one, but its corresponding side is also across from it down here, like so. And last but not least, we have angle C. That's the angle that's left. And across from it is our side C. So another thing to remember is that we typically use lowercase letters for sides and uppercase for angles. So now that we have that labeled and we've got the formula, let's go ahead and get started. One thing I almost forgot to mention is that you might also see the law of sines flipped, with your angles on top and sides on the bottom. That is okay, as long as you have it consistent through each part of your formula. Now let's go ahead and get started on our example. We are given that angle A is 71 degrees, angle B is 42, and side C is 15. So I see that angle A is here, and side A is here. Angle B is here and side B is here. And angle C is here and side C is here. So one thing we need to remember is that all three angles of a triangle equal 180 degrees. So we can figure out angle C by doing 180 minus 71 minus 42, which if I do that in my calculator, we get 67 degrees. So we know angle C is 67 degrees. Let's do that in green since that's what we found. Now let's figure out what side A and side B equal. And now we can use our law of sines. So you're going to want at least one angle side pair. In this case, we do have side C and angle C. That is perfect. So I'm going to go ahead and set up our formula. We're going to put side C over sine of C. And then let's solve for angle or side A first. So I'm going to set that equal to little a over sine of A. Now we can plug in our formulas. Okay. So side C is 15. Sine of C is 67 degrees, as we just calculated. We don't know what A is, and we know sine of A is sine of 71. Now, we have an equal sign separating the fractions, so we can actually cross multiply here to give us a times sine of 67 equals 15 times sine of 71. And then I want to get a alone, so I am going to go ahead and divide both sides by sine of 67. To cancel this out, that leaves us with a equals 15 times sine 71 over sine 67, which we can just plug into a calculator. So to do this on a calculator, we're going to do 15 function sine of, well, let's see, it was 71. Close parentheses. Now divide that all by sine of 67. Now make sure your calculator is in degrees, and we got 15.4. So we know side A is 15.4. I've gone ahead and moved my work over here. We know side A is 15.4. Now let's look for side B, which we're going to do basically the same process. So we know C over sine of C. And you could use A now if you want to, but I'm going to stick with C. And then we're going to set that equal to B over sine of B. Plug in our numbers. 15 over sine 67 equals B over sine of 42. Let's go ahead, cross multiply. We got 15 sine of 42 equals B times sine 67. Now I want to get rid of sine 67 to get B alone, so divide both sides by that. And we are left with 15 sine 42 over sine 67 equals B, which we can plug into our handy dandy calculator. So 15 times sine 42, close parentheses, divide by sine of 67. And that gives us about 10.9. So we know that is equal to 10.9, which you can plug in up here. And we have solved our triangle. And we're done. So when do you want to use the law of sines? Real quick, we will use the law of sines when given an angle side angle case or an angle angle side. We can also use it during side side angle, but that is a little more complex, which we'll cover in a later video. But let's look real quick. Angle side angle. You'll be given this angle, a side, and another angle. And it could be any two angles but the sides in the middle. Angle, angle, side is where you're given a side on the outside. So those are the two cases where you're going to look for using the law of sines. I'm going to let you go ahead and practice now. If you have any questions, feel free to let me know in class or through email or text or Canvas. And I'll see you in the next one. Have a wonderful day. Bye.